In this lesson, we will discuss the automatically operated switches which may be found on an aircraft. They include microswitches, proximity detectors, time switches, bimetallic switches, and centrifugal switches. We will examine each of these types of switch, beginning with microswitches. Microswitches are used in modern aircraft to detect the position of a particular device, although on landing gear installations they have largely been replaced by proximity detectors. A microswitch operates in the same manner as a momentary action switch light, except that instead of the switch being operated by the pilot's finger, it is fitted with a plunger, which operates the switch when it comes into contact with the striker plate fitted to the component being monitored. In the typical example shown here, the moving contact is on a spring arm, which will hold it against the upper contact. When the component being monitored reaches the required position, the striker plate will push down on the plunger, causing the moving contact to move down and connect with the lower contact. Shown here is the Boeing 747 flap lever, which has a number of microswitches fitted to warn the crew of flap failures. Bimetallic switches are temperature-sensitive switches, which operate when a certain temperature is reached to provide an indication to the pilot or to activate or deactivate a circuit. The switch consists of a bimetallic strip made up of two strips of dissimilar metals bonded together. The strip is fixed at one end, with the other end free to move up and down. The free end has an electrical contact on it. At normal temperatures, the strip is straight. In our example shown here, when the strip is straight, its contact is touching a fixed contact. When the switch is heated, the two metals will expand by different amounts, and the bimetallic strip will bend. This causes the contacts to open, breaking the electrical circuit. Bimetallic switches are often used in battery charging circuits. The switch is placed in close proximity to the battery to monitor its temperature. Should the battery temperature become excessive, the switch will operate to shut off the charging current and put on a warning light. Proximity detectors are electrical or electronic sensors that respond to the presence of a material. The electrical or electronic response is used to activate a switch, relay, or transistor. There are many types of proximity detectors. The major types are inductive, capacitive, and magnetic. The inductive and magnetic sensors need the monitored target to be metal, but the capacitive type can monitor either metal or non-metal materials. The first type of proximity sensor that we are going to look at is the inductive type. Inductance is a property that a coil has when it has an alternating current, or AC, pass through it. Inductance is fully explained in the AC part of the syllabus. For the moment, all you need to know is that the inductance of a coil with AC passing through it changes when it is brought into close proximity to a suitable ferrous material, and that this change can be measured. It is important on aircraft with retractable landing gear systems that the pilot is kept informed of the position of the landing gear. On older aircraft, this is achieved by using gear-operated microswitches to operate indicating lights. On modern aircraft landing gear, inductive-type proximity sensors are used instead of microswitches. In a typical undercarriage system, each proximity sensing unit will consist of three components. An electronic circuit, which is contained in a component known as the landing gear accessory unit. This circuit is able to sense changes in inductance and switch the appropriate gear light on and off in response to these changes. A sensor, consisting of an AC coil located on an appropriate landing gear structure. and a ferrous metal target for each sensor. When the part of the gear being monitored is in the correct position, the target and the sensor are in close proximity to each other. This changes the inductance in the coil, and the electronic circuit will then produce the appropriate indication. The inductive proximity sensor is a hermetically sealed unit and is actuated by the presence of the actuator or target. It is not touched by it. There are no moving parts. As a result, this type of switch is unaffected by atmospheric conditions and is highly reliable. Now we will look at the capacitive type of proximity sensor. Capacitance is a property that two plates of a suitable material placed in close proximity to each other have when an alternating current is applied to them. Once again, this is fully explained in the AC part of the syllabus. For now, all we need to know is that the capacitance of the plates will vary if the gap between them is filled with different materials, and that this change in capacitance can be measured. Capacitance type detectors can detect changes in all materials, both solid and liquid. They are widely used in aircraft fuel quantity measuring systems. A typical capacitive fuel measuring device consists of two concentric tubes of metal with an AC supply across them, standing upright in the fuel tank. The gap between the two tubes will be full of air when the tank is empty, and full of fuel when the tank is full. At intermediate fuel levels, the gap will have part fuel and part air. The capacitance of the device will change as the proportion of fuel and air changes. This capacitance is measured and displayed on a gauge as fuel quantity. The final type of proximity detector that we are going to look at is the magnetic type. Once again, magnetism is a subject which is covered fully later in the syllabus. We will take a very quick look here at the properties of magnets, only in sufficient depth to see how this type of detector works. A bar magnet is a metal bar which displays magnetic properties. One of the properties of a magnet is that it is surrounded by a magnetic field. The lines of force or flux of the field come out from one end or pole and return to the magnet at the other end. If a coil of wire is moved through this field, cutting through the lines of flux, an electromotive force or EMF will be induced in the coil. If both the coil and the magnetic field are stationary, no EMF will be induced. There has to be relative movement between the lines of flux and the coil for an EMF to be induced. Another property of a magnet is that if a suitable ferrous material is placed near a pole, the magnetic field will flow through that material before returning to the opposite pole. It is these two properties that are used in the magnetic proximity detector. In a simplified magnetic proximity detector, a coil is wound around a bar magnet, and one pole of the magnet is then located close to a ferrous object. If the ferrous object moves, the magnetic flux changes, causing the force lines to move through the coil, and an EMF is induced. If a number of ferrous objects move past the magnet, a train of pulses is induced in the coil. The speed or frequency of this train of pulses can be measured. Magnetic detectors are most commonly used in conjunction with mild steel gear wheels, each tooth in the wheel being, in effect, a ferrous object. The detector is located close to the periphery of the wheel and provides an output having a frequency equal to the frequency of passage of the teeth past the detector. This frequency will be proportional to the speed of rotation of the wheel, so it can be displayed on a gauge calibrated in revolutions per minute, or RPM. Time switches or relays can be initiated electrically or mechanically to activate a circuit after a specific time interval has occurred. A time switch is often found in an aircraft's auxiliary power unit, where it will close the air intake door after a specific time delay after the auxiliary power unit has been shut down. Time switches can be simple wind-up mechanical switches, like this galley hot cup controller, or, more probably, on modern aircraft, solid-state electronic devices. Centrifugal switches can be set to activate or deactivate a circuit as the rotational speed of a device increases or decreases. In the simplified diagram shown here, the flyweights are being driven around by the component whose rotational speed is being monitored. As the speed increases, the flyweights move out, pushing the non-rotating sleeve against the spring, which in turn moves the lever arm. At a specific rotational speed, the lever arm will close the switch contacts and an electrical signal will be sent. Centrifugal switches are commonly used to switch off engine starter motors once the engine reaches self-sustaining speed. That is the end of the lesson. Here are the main points. Microswitches are mechanically operated by a striker plate on the component being monitored. Bimetallic switches are temperature-sensitive switches, which operate when a certain temperature is reached. Proximity detectors are electrical or electronic sensors that respond to the presence of a material. They have no moving parts. Inductive and magnetic sensors respond to the proximity of ferrous materials, but capacitive sensors respond to all materials. Time switches or relays can be initiated electrically or mechanically to activate a circuit after a specific time interval has occurred. Centrifugal switches can be set to activate or deactivate a circuit as the rotational speed of a device increases or decreases.